Thank you very much, Matt. And it's wonderful to have the opportunity to talk to you all today. So, as we said, please do put any questions that you want into the chat. I will do my best to answer them all. If I can't answer them, I'm sure I can find out an answer for you. Okay, so without much further ado, today I'm going to be talking to you about 3D concrete printing. I know for those of you who are regulars on these talks that you have had one at the beginning of the year. So I will only very briefly be touching base in terms of what 3D concrete printing is, but I'll be focusing more on the more recent advancements that have been made both globally and locally and seeing how it all fits in. So I'll do that brief introduction, look at the global progress, look at the local, and then what this means to us. What are the opportunities that 3D printing is offering us? What are the various challenges? Because, well, there are always challenges. And where's the road ahead? The road ahead will obviously be what my personal feelings are about the road ahead, but I'm always keen to hear everybody else's opinions of it too. I have broad shoulders. I have been told by somebody, which I had a chuckle at, that they do not believe in 3D printing. So believe me, you're not going to offend me at all if you want to have a healthy discussion about the merits or advantages and disadvantages of it. So what is 3D printing? Well, basically, the easy version is it's a cementitious additive manufacturing method for building elements or structures. We know conventional 3D printing, whether they're home printers or large scale, we're just doing it in concrete, and I use the concrete phrase carefully here, but certainly within a cementitious material. There are numerous different types of 3D concrete printing. They depend on what you are trying to achieve, the nature of the machinery that you have. A lot of them are standard extrusion-based additive ones, which I'm going to cover in more detail going forward. But there are also something which is commonly known as binder jetting, where you have material which is in a bed already, and then effectively what the robots are doing is they're extruding a binder, which is tying the material together. So that's also a very common one. I'm not going to go into details on all the different types of manufacturing. I'm going to be primarily focusing on the extrusion-based 3D concrete printing, like you can see in this particular picture here. So typically what is happening here is you have a cementitious material, depending on the scale of your nozzle and the size of what you're trying to achieve. That's either a mortar or with fines in it, where the biggest material sizes are typically speaking smaller than 4 or 5 or 6 millimeters, or it can be a full concrete with actually large aggregate in as well, depending on your purposes and what you're trying to achieve. These layers, this is then extruded in layers. It needs to be soft enough to be extruded out and still be able to adhere to the layer below it, but at the same time, it needs to be what we call buildable enough that it can form a structure and actually have strength and not collapse during printing, because that would get a little on the messy side. So that is what it is. Where are we at the moment? So there is, whenever you have new technology, there's a massive amount of hype and enthusiasm for it, and then it goes through various dips, and you end up with the whole hype Gartner curve where it discusses what the progress is and people get disillusioned and things like that. Now, 3D concrete printing became a little bit more mainstream in about 2016, where it just started to develop. There were a substantial number of projections looking at how they thought the curves were going to go. If you look over here, the green symbols on this curve are typically predictions that were made in 2018, 2020, and 2022 for what they were anticipating was going to be happening from 2027 to 2030-ish. So they were anticipating that concrete printing would reach about 0.05% of the global share for construction by 2030. But most of these trends are actually being exceeded now. So the blue symbols are actually the more recent trends which have been developed, where they are showing that that's actually trending towards a higher share. Note, we're not saying that all concrete which is ever going to be built on a construction site is going to be 3D printed. That's not what it's there for. There is still very much a place for conventional concrete. These are more niche situations where you would be using 3D concrete printing. Okay, so what is it that we're actually printing at the moment? And where are we printing? So the vast majority of the printing work which is being done is on houses, single story, double story, wide range of different sizes. These are typically speaking made with large gantry cranes where the entire structure is printed as one, or at least in printed segments by an overhead crane. There are also other types, for instance, infrastructure, various types of street furniture, bridges, and others. I'm going to cover those in a little bit more detail. Now, this graph that you see here was actually formalized in 2021. And you'll see there the publications at that stage were sitting at about 430. I did a search 2 days ago to check what I'm going to say is the pre-2026 publications. They're currently sitting at 2,117 publications, purely with the focuses of either 3D printed concrete or 3D concrete printing as the two search words that I had a look for. So there is, between 2021 and now, there has been a massive amount of increase in terms of the research of how we use these materials, what are suitable materials, and how they all get integrated. So in terms of where we are printing them, you will see the vast majority of these cases. Again, this is a slightly older graph here because this is actually from 2023, this little pie chart on the left-hand side. So the majority of the cases have been printed at that stage in North America. That is probably still true because of the fact that they are printing housing estates. So there are numerous houses within the individual projects which are happening there. But there is actually a fair spread of projects which are being developed all over the world. So if we focus a little bit more on what is actually being built viably, commercially, and actually constructed at the moment, residential is, as I've said, the main one. So over here, I have two examples of the 3D printed houses. The first one is the Grange Close development in, I think you pronounce it Loch Island, but I apologize if that pronunciation is wrong. This structure is a double story. It's council housing. It was created, well, it was requested by the Loch Council. They engaged with the contractors and they built it because they have a massive housing shortage issue. And it was built 100% according to codes, the material according to material codes. The designs of the walls were all done according to the masonry code, not the concrete code. And it adhered to all that regulations and was approved, and there are now families living in it. And this one is one of the few double-story council development houses that we're seeing. But this one was not purely a prototype. It was more the first of an entire range of houses or developments which are being built. So there are a lot of, in 2022, there was a paper done that said that the technological readiness level of 3D printing was sitting at a 6 or a 7, which means it's primarily prototyping. When it comes to residential blocks, we've moved quite far along from that. They are now, at least in the areas of the world which have the equipment and the machinery and they're running with it, it's a viable option. So if you look, for instance, at this video, you are seeing this is the Wolf Ranch in Texas, built by Icon. There are 100 3D printed houses. These are the completed houses that you're seeing in the video. And then this is just a random gentleman driving down the road. This is not marketing material. He thought it was interesting, so he shared it. And then on this side now, you will see the houses in construction as they're busy being built. And these are whichever scale is necessary. This is not council housing or RDP housing. These are fancier houses, but the variability in terms of the sizes are there within the housing markets. Okay, but other than houses, because houses are great, but if it's just houses, maybe it's not as useful as we think it is. So where else are they being used? Okay, so they are practically being implemented. This isn't just prototyping, they are practically being implemented in terms of bridges. Over here on the left-hand side, you've got the concept of a mini-mass. That is a trademarked beam system where effectively 3D printing is being used to purely put material where you actually need it for concrete bridges. This was in a particular development, but they have since had contracts for 3 others within the same development bridges. These are pedestrian bridges, but they are well capable of taking loading in excess of a pedestrian's loading. And they've also got a contract for building, repairing bridges in the Ukraine, because they need bridges obviously in a hurry, and there's been infrastructural damage, which you now need to be able to replace. These are elements which are cast or printed in a factory and literally just loaded onto the back of a truck and moved. They're lightweight, they're easy to move, and very minimalistic, and yet function exactly how they should be. So those are something that have been practically implemented in several locations. You also have the slightly more exotic and pretty bridges here. This is Phoenix Bridge. This one is an evolution of the original bridge, which is striatus, and it is technically a disassemblable bridge, but it is still, I don't want to say it's a prototype because the previous version was the prototype, but it is a novelty bridge. It is there to create an impression and demonstrate what it is capable of doing in terms of shapes and sizes and things like that. But it is not just bridges, and it's not just houses. You are also using them in projects elsewhere where you're not just looking at it with the entire structure being cast out of 3D printed concrete. They're being used as elements. So whether that is now creating shaped void formers within actual concrete slabs, because you can make, for instance, in this bended slab over here on the left-hand side, that's very similar concepts to a coffer slab, but obviously coffers have constraints when it comes to the sizing and the patterns of the coffers, and it can actually be quite difficult to reinforce, and you end up with step changes and things like that as well. So now if you are using a lightweight concrete void former instead, that can be very versatile and save quite a substantial amount of weight. Those aren't solid, in case anybody is wondering. They are, it's a network that forms a lattice, so it's voidable. And then on the right-hand side, you see the concept of something which is called foam work. This is not true printed concrete. This is actually a foam cement, which is used to be able to cast slabs, which is minimalist slabs. So you literally have the concrete where you need it, as opposed to occupying the full depth and the full weights that you sometimes get with slabs. And this material can then be, you can leave it in place, but it can also simply be removed or washed out and then reused. It's made from recycled material as well. And that can be used to create it's printed, which effectively forms as then formwork where you're casting the concrete between it. So these are all different options where they are currently being used. It's not just that though, you're also using it in prototype structures. So there's a lot of research which is currently being done into segmented structures, in particular along the lines of the sustainability side. So reuse, recycling, things like that, and minimizing the actual amount of concrete that you use in your overall structure. So this is one called the minimal vault. It is a 9-meter spanning vault, which is made compression only structure, which was made. This is a prototype. It's not one that is commercially being implemented around the world, but it's to demonstrate the potential and the viability of these. There's a similar one as well, also made segmented compression-only structure, which you can use to create phenomenal different shapes and sizes. So if you can pretty much dream it, you can implement it. So these are some of the prototype systems which are being displayed at expos around the world. They're not, I would say, as far along in terms of the implementation as the houses or the bridges that I was showing you earlier, but these are very much situations just demonstrating the versatility of the material itself. Then if we look at personally my favorite current structure, and yes, I am allowed to geek out about current pretty structures. You all want to do yourselves a favor and you want to go to the webpage that I have given the link to there and have a look at tour over. This is a 30-meter tall 3D printed building. It is made from segmented pieces, so just like you would with your precast concrete. They were made in a factory, they were shipped, and then they were all erected together on site. But these elements are all lightweight, minimalistic 3D printed elements. There are 32 columns. Every single one of the columns in the entire structure is unique. It is in a place called Mulgens. I'm not sure I'm pronouncing that correctly, but in Switzerland. But it is quite a landmark structure. So if you would like to see, they've got lots and lots of videos on their site. If you would like to see some very pretty structures and the whole unveiling, I would strongly suggest going to have a look at it. It is quite remarkable what you can achieve in terms of the delicate lattice work and things like that. Okay, but it's not good enough to just be able to print these kinds of systems. What's the progress we're actually making with the printing systems themselves? So in the last couple of years, when it comes to the printing systems, there's been a fair amount of progress. I've demonstrated here on the left-hand side the typical gantry crane. This is what you are using for when you're printing the entire structure. Those have become bigger, bolder, more reliable, taller. When they're printing the neighborhoods with them, they put the actual gantries themselves on tracks at the bottom, and then you print one house and then track it down to the next one and remove the rail behind you. That's on the left-hand side. When you're looking at the one on the right, that's a robotic arm. The robotic arms are typically speaking used for the off-site fabrication rather than the large-scale on-site. And the degrees of freedom that you can now print with have improved substantially. So over here you'll see Vertigo's printer. It's effectively a 6 degrees of freedom printer, and it allows you to not just print in horizontal layers, but to be able to move that as well so that you can print at different angles and different layer thicknesses. So there are internationally quite a lot of advances. It's not just good enough though to be able to print at these kind of angles if you don't have the right forms of mixers. So what we're actually talking about when it comes to what is the mixture involved, there have to be advantages and advances in that. Now, this is probably the area where there've been some of the most improvement in the last almost decade since 3D printing started. When it started, you will have seen one of the main negatives that was held against it was very, very high in cement. The cement ratio was very high. So it wasn't regarded as being particularly good in terms of sustainability, because even though you could make a reduced cross-section of an element, your actual cement that you were including in it was so high that it detracted from the advantages that you were getting. So there is substantial progress that has been made. Quite a lot of that progress has been made here in South Africa, but I'll cover that a little bit later. And you will see that as we're getting more current, your ratios and the integration of the construction and demolition waste and your supplementary cementitious materials are now an increasing proportion of it. So the actual cement that you're ending up being used can be very similar to that which you would use within a normal concrete mix. There's still places to go. The introducing of larger aggregate sizes is still an ongoing discussion, because not all of the robotic systems suit the large aggregates. But yeah, there's always future study work still to be done. But it is very common now for quite a lot of the items to be printed with up to about 8mm stone. Some are printing with full aggregate sizes, in particular the houses. But it used to be that people were printing only with 2mm stone with fines. So there is noticeable progress happening in these regards. Okay, other progress materials wise, it's very important to have local materials used, because if you're not using your local materials, you are running up the costs of it to make it impractical. But in Europe and in America, and I think Asia as well, it is now possible to acquire ready mix bags. So you can actually do ready mix concrete, which is pumpable concrete. So for instance, that Loft Country Estate, the Grange Close that I was showing you earlier, that was entirely printed from ready mix trucks, arriving with printable mixers and discharging them into the pumps and then being printed accordingly, which does simplify some of the systems rather than batching it on the site. There are differences between the mix. You are far more likely to be using a mortar mix if you are making delicate elements, or if you are, for instance, creating formwork out of your 3D printing, rather than if you're doing the bulk printing like walls for a home, where you're more likely to be using the full-scale concrete mixes. Now, one of the main issues that we have with any new technology is, how do we integrate this? How do we get it approved? At the moment, most of the structures that have been built have either relied on one of three measures. They've either relied on within the Euro code, and in fact the ACI codes and the South African codes as well, there is an option for design by testing, which means that if you can validate through largely full-scale testing that it is appropriate and that it will be fit for purpose, then you can actually construct items. This is an extremely expensive way of doing it, because you basically have to build your elements twice, which is not ideal. But it does allow you to be able to make progress and be able to design and create the prototype systems. The second way that it's been approved, most of the houses have been approved based on the masonry codes, because there is quite a lot in common between 3D printing and masonry. It is anisotropic, so unlike concrete, conventional concrete, which has similar strength in all of its directions, obviously the layering of the concrete itself for the printed concrete quite strongly affects the strength in the different directions. So it performs in a more similar pattern to some of the masonry codes in terms of its behavior. And then the third way that people are getting around it is by, hang on, I think I've done design by testing, the masonry code, and oh yes, just using it as formwork, so not actually relying on the strength of the concrete itself. So embedding steel structures or concrete and reinforced concrete columns, say for instance, inside a more decorative column, which again is not extremely useful because it detracts from the actual efficiency. It is a load-bearing material. It can take load, so we might as well be using it rather than just treating it as formwork. So, however, there are developments which have been made. So, for instance, Dubai in June 2024 released an entire collection of guidelines for 3D concrete printing and design and construction, how to use them. The United States have a collection of items for general automated construction technologies, and in particular, they have now got the ASTM 52939, which is additive manufacturing for construction, which is basically 3D printed concrete. That is less design principles and more talking about the process and the systems and how they should be implemented. Then you have additional codes which are currently in the process of being developed in America on the 3D printed walls, because they are the most common use that they're getting out of them in America at the moment. So there are guidelines which are being developed. This is not an exhaustive list. There are many others. Those just happen to be the ones that I've got here at the moment. Okay, so globally, we know that there's progress being made, but I find sometimes we sit here, we're towards the southern tip of Africa, and we go, that's fine, but what does this mean to me? So something we shouldn't underestimate. We have a tendency to undervalue sometimes the work which we are doing here in South Africa. So I'm gonna temporarily brag here for a little bit. This is a search that again I did 2 or 3 days ago on Scopus, which is a document repository where you can access papers and things like that. And I simply put in 3D printed concrete or 3D concrete printing and saw which universities were producing detailed information on them. And of the top 10 universities in the world which are producing that, Stellenbosch is currently doing pretty well. It is South Africa is not behind in research in 3D printing. It may seem like it is because you're not seeing the housing estates going up in the same way other people are. But we're actually quite comfortably world renowned as on top of the game when it comes to 3D concrete printing. So what are we doing in terms of physical printing houses? Well, University of Johannesburg has, you would have seen in the news in 2023, they printed a house in 8 hours. That was a combined work from the University of Johannesburg Department of Science and Innovation and the Department of Human Settlements, KZN. So that was to evaluate the potential of using 3D concrete printing in terms of our RDP houses. They are also currently in the process, my understanding, is building a guardhouse at the University of Johannesburg as well, testing local materials and things like that. So those are current printed structures which have happened in South Africa. They're not the only projects which are underway. They are also, this one's my little baby, so I might get enthusiastic talking about it. But this is a reusable column segment. So the idea here is that you end up with, basically it's Lego with 3D printing. The column segments you put in post-tension reinforced, post-tension steel into the openings. You have a central area which is there, which you reticulate services in. And if you look, then it becomes basically a segmented column which can be erected and demolished and relocated into other places. So there is work and research, quite a lot of it, which is going into this kind of work. And the next item then is integrating that into how do we make it functional for you guys, the people who are listening in on this call. How do we take 3D concrete printing and we make it something which is not pie in the sky or something that happens elsewhere? How do we integrate it so that it becomes yet another tool which is available to the structural engineer and the architect here in South Africa? And the easy answers there are, honestly, there's a lot of pretty pictures and graphs here, but it's very, very similar to precast concrete. You need to integrate people at roughly the same sort of stage in the project. A little bit earlier would help because nobody's as familiar with the technology. And you need to have a subcontractor who is capable of doing the printing. And otherwise, it is very much the same sort of thing. Obviously, if you are printing the full structure that you are doing, if you're making a house or something like that, and you're doing a large gantry printing, that is a little bit different. But if you are printing elements within your overall structure, it's very much a similar system with the precast printing that we're all very well familiar with. There are a few things that we're looking at developing in terms of making that easier. A handbook like the precast concrete people have, just to explain what is and isn't possible with 3D printing, and various details and things which come back from that. But that's work in progress at the moment. Okay. I then extended the phrasing local here. So, and I'm claiming Kenya as well. But yes, we are not the only people in Africa which are doing 3D printing. There are 14 Trees is busy printing. It's a company printing all over the place. This particular these photos come from Mbule Gardens, which is in Kenya. And in addition to these, so these are houses. They are effectively eco-friendly houses. They cost 2.9 million Kenyan shillings. You can buy them for not what they cost to build. That's what their price is to buy an apartment of them, which roughly equates to 319,000 rand, based on my very brief exchange rate calculation. These are 56 square meter houses, and they are larger than what we would typically speak as in terms of an RDP house, but it performs a similar sort of function. 14 trees in addition to this. They've built classrooms in Madagascar, schools in Malawi. They've got an IFC EDGE certified building in Nairobi, and sustainability-wise, these are showing very good progress compared to the conventional concrete construction of them. Okay, so we've covered some of the projects we're working in. What about materials? So it turns out we've got great local materials which are available for doing 3D printing. There is a lot of work and details being done on them, not just the structural influences of them, but also the thermal comfort. How do we build the wall to make sure that between the outside and the inside we don't get as much heat propagation, so it just makes the whole place more energy efficient? How does the lattice and the infill patterns work? Do we need the infill patterns? Can we just get away with shaping the wall edges to provide stiffness instead? Huge amounts of work which are being done on that, and the durability of it, the stresses and the strains, the actual finite element analysis, and options in terms of reinforcing them and whether we can use them for facade panels as well. So we have the materials, they are functional. Some of those material details that I was showing you earlier within the globe wall picture, those have been actually quite a lot of it done from our labs here. So we have mixes. Our standard mix that we've been using in the labs here at Stellenbosch has 25% construction and demolition waste included inside it as well. So there are a lot of benefits and movements which are going forward in terms of the mix design at the moment. Okay, it's not just that. In terms of the printing systems, one of the issues with 3D printed that we've had historically is the interlayer weakness. So you end up with you can end up with almost a partial joint between the two layers. So we've done various studies in terms of how do you improve that interlayer interlocking. So how does it affect if we steam it, if we change the different nozzle patterns, how do they all link together, and are getting very good results in terms of the integration, which makes the entire structure stronger. Okay, local codes for us, however, what do we do there? So we do still have the same systems as most of the rest of the world, where we have the rational design or a rational assessment. We also have a design assisted by testing system, and you can get the agreement certification and things like that. At the moment, there aren't any agreement certifications for 3D printing in South Africa, but there are for other systems which are semi-similar to those, but at the moment there isn't one for 3D printing. So you would need to do full designs assisted by testing and items like that at the moment. We are, however, busy looking at developments in terms of how do we integrate it into the new concrete code. So for those of you who are not aware, South Africa has a new concrete code. I'm hoping everyone's aware. But if you're not aware, we have a new concrete code. If you want to learn more, I'm going to be running a lecture, a short CPD course next year. So stay posted and I'll let you know. But our concrete code has changed from 10100 to 51992, and it's adopted the Euro code. And that is the Euro code that we adopted was a modified version of the 2004 Euro code. But for those of you who are in the know on the Euro code, there was one released in 2023. So our new SANS code has to be revised to its next revision to update and incorporate the modifications that the Euro code made as well. But that's the nature of codes. At the moment, you will see at the ends of those, you have chapters 10 and chapter 12, which are additional rules for various specialist systems, precast concrete or plain and lightly reinforced concrete. The idea that we're looking at here is that that will be very much the same idea, only we're going to be trying to incorporate the additional rules for 3D concrete printing. How is it divergent from the normal one? How do you include it? There's lots of test data which is now available to be able to start guiding the direction of these kind of guidelines. So that is some of the work which is currently underway. Good. Okay, so I've now swamped you all with masses of uses, global, local. Why do we care? What's the advantage of this? Where are the opportunities? Okay, so there are lots of potential opportunities. The ones which are probably the easiest to understand is the geometric flexibility that it offers. You don't need formwork. And with not needing formwork, honestly, we become limited only by our own imaginations. I find I really battle with this one. I'm a bit of an engineer when it comes to thinking in straight lines, but I'm desperately trying to retrain myself to understand the advantages of curves. And it is truly beautiful to be able to see how we can create some of these shaped structures. In addition, that comes strongly with the idea of optimization. So the form follows force is actually something we can implement now. We don't need rectangular beams because we can actually have more efficient structures that can be constructed. This particular one in the image here is actually binder jetting rather than the extruded additive manufacturing of concrete, but it's all part of the same umbrella terminology here. So there is a lot of optimization work. We understand how to optimize it. It already piggybacks on the existing field of structural optimization. It's just applied with the constraints of 3D concrete printing. All of this gives us quite a lot of benefit in terms of sustainability. If we can use less material, I'm sure everybody is hearing all the jumping up and down about just how bad concrete is for the environment, and the manufacture of cement is a leading cause of that. And we use it in a very, very large number of places. So if we can reduce the amount of material we're using, just put it where we need it, integrate it better into the natural environment, it will help us in terms of our sustainability goals. Okay, in addition, speed of construction, it's fast. That's assuming the pump is working and the printer's working and nothing gets blocked and problems don't happen. I'm sure many of you have pumped slabs before, so you'll understand that if the pump breaks down, then obviously there is delays to the construction process. That can happen here too. But if everything is up and running, it is fast. It is much faster to build some of these than it would be to actually build it in the more traditional methods. That Lagrange close building, the double-story one from Ireland I showed you, that was 3 days to set up the printer and get everything aligned. The actual print itself was done in 12 days of that entire double-story structure. And then it was another 3 days to pack up the gantry crane and move it off-site again. So it's fast. Safety, the idea is honestly a lot of the problems that happen in terms of safety are because you've got a large number of people working in and around heavy equipment the whole time. If we can improve this with robotics, then that does help in terms of a safety perspective. Obviously, the social impact of that is another question, which is still coming up. So, digital integration, for those of you who are aware, we are currently in South Africa adopting the ISO 19650 workflows and all the BIM systems. How does this integrate? Well, the answer is it integrates quite well. Obviously, you need 3D models, you need information exchanges anyway as part of all these systems, and you need those for 3D printing as well. There are still some inefficiencies because a model that an architect will create for a building is not the same as a model that a structural engineer will create, which is not the same as a model a printer will need for to create an object. So there are still some inefficiencies transitioning between those, but that's something that comes with time. Okay, so why do we not just use it everywhere? Why is it not the default go-to? Okay, well, it's never going to be something that replaces all of concrete on a site. That's not the point. There are technical challenges. How we get the reinforcement in is a problem. Here you will see, this is the picture I have here from Acres Core, is they're using it as effectively reinforced formwork, so they're still casting inside the 3D printed elements with reinforcement. It doesn't integrate particularly well with reinforcement across the layers. Within the layers, absolutely, you can put in fibers, you can lay elements between them, but across the layers, most commonly it is either done like this, or you are using post-tensioning occurring afterwards. It's a very common way of making it work, and it works well. Some of the structures are focusing more on compression-only structures as well, where you do not need masses of reinforcement. So there are ways, and there are robots that can integrate across the different layers, whether it's stud welding or threading bars in, but invariably the more you do in that line, the more expensive it ends up getting. And it needs to be practical, it needs to be comparable to conventional concrete. Okay, regulations, I've covered them in a fair amount of detail, but we do still need established regulations to make it all happen smoother. They're coming, but it is still currently a holdup. And obviously then the social impact. America is finding it incredibly useful to build social housing from 3D printing. We do not necessarily have the same difficulties that America have. They have a problem where they have minimal labor available. We have a considerable amount of unemployment, so we don't want to contribute to that by stealing people's jobs away. On the other hand, new technologies bring with it new job opportunities as well. So whether or not 3D printing is an answer to South Africa's housing concerns, that's not something I can say. We have different problems to the places where it is a solution, because it definitely is in some places in the world a solution to the housing concerns. But our difficulties are not necessarily the same as Europe's and America's. So you must consider things within that local format. Whether it is or not, I do not yet know enough to judge. Okay. But despite these challenges, we need to look at the road ahead. Where are we going to from here? What's possible? The way I see it, it gives you the opportunity to do some stunning architecture that you wouldn't even dream of at the moment. Whether it's just as simple as facade infill panels and things like you can see there, it still helps you create. I mean, you can imagine a column which is entirely shaped like a tree. It's doable. You can make that. We have the opportunity to make highly efficient structures. Our structures currently are not super efficient. They're built for speed of formwork and erection and things like that, whereas they can be considerably more structurally efficient. And also it has quite a lot of knock-on effects of places where we wouldn't typically be able to use a material like concrete. We can now. So you will see in lots of things like here, they're making man-made coral reefs out of a 3D printed concrete, and they're successfully doing it, implementing it both in ocean areas as repairing coral and in aquariums, and allowing they encourage the growth of all sorts of algae and seaweed and things like that, and help rehabilitate entire coral reefs. And this is something which is already being done, but we're only starting to scratch the surface of what is potentially possible when we're looking at these kind of free form and efficient things. There are many, many other advantages too. We are limited by our own imagination here. So if you have ones that you think could be a brilliant opportunity for it, feel free to come and chat to me. I'm always keen to engage in discussions about where we can use it and how we can use it. And then the last thing I just want to end on before the questions here is there are lots of courses around the world where you can do CPD points. The one I don't have on here, and I should have on here, SAPSA and University of Johannesburg have got a 2-day course in addition as well. Stellenbosch will be offering a several-day course, probably starting from about 2027. in 3D concrete printing and how to use it and how it works and how to print. So yes, that is us. I hope you have enjoyed the conversation